w13x. This is a worked example of how to find the maximum number of beams through a given diffraction grating. So we have our formula from the formula sheet. N lambda equals d sine theta. And just to remind you, that forms bright spots in particular directions, numbering outwards from the 0th order straight ahead beam round to the side, but not backwards. So the greatest that this angle can be here is 90 degrees. So we want to know how many bright spots we're likely to see. So if we use the fact that the greatest value of theta is 90 degrees, that means the greatest value of sine theta is 1. So if we rearrange the formula and put sine theta equals 1 in, we get n equals d over lambda, d times 1 over lambda. So just to remind ourselves, n must be an integer because you can't have a fractional fringe here. There's either a fringe or there isn't, but it's got to be a whole number. So let's have some numbers. Let's say we use an 80 line per millimetre diffraction grating. We use a red laser which has a wavelength of 632 nanometres, and we want to know how many bright spots we will see. So if d is an 80th of a millimetre, that's 0.0125 times 10 to the minus 3 metres. All these values must be in metres when you put them into the equations. So here's our equation, n lambda is d sine theta. And we put in the limiting case of theta is 90 degrees, meaning sine theta is 1. So rearrange, we get n is d over lambda. Put in the numbers, all in metres, so not forgetting to convert nanometres to 10 to the minus 9 metres. And that comes to 19.8. Now obviously we can't have 0.8 of a fringe, so we wouldn't see the 20th fringe, but we would see 19. So the answer to the question is there would be 19 fringes, counting from the centre one, the 0th fringe, outwards. If you had the same laser but a grating with 300 lines per millimetre, then we do the same thing. So assume that maximum value of theta is 90 degrees, so sine theta is 1. Rearrange to get n is d over lambda. Put in the numbers again. So 300 lines per millimetre is a 300th of a millimetre, and times 10 to the minus 3 converts that to metres. Over 632 nanometres, and that comes to 5.27. And again, we can't have 0.27 of a fringe, so we wouldn't see the 6th fringe, but we would see the 5th one. So we would see centre bright spot and then 5 bright spots on either side with this particular grating.